I'm going to do a redraw, because that's the first thing you're going to do anyways. The top left one, they're handwritten for the H-shaped ones. I'm going to move that over a little bit. I'm going to, maybe this,
It's 45 volts.
40, oh, you want to do the,
Oh, okay, my bad.
No, it's 30 volts.
I'm going to jump a step, and I'm only doing this. Oh, this one looks familiar. We did this one earlier. I've jumped a minor step just to keep, and I did it intentionally, not to keep from doing the work, but to get it in your head, to get past those two resistors in series.
What were the values for those two resistors?
They're 175, 125. Did you not get one of those sheets? Anyone else need one of these? All right. It's that problem. So to simplify, just to get past that, those two resistors, R4 and R5, tend to be a little confusing. So I'm just going to lump them all together. They're in series. So look at my redraw and look at this on the top left and make sure that there's no confusion as to what I've done and what I've drawn. I'm going to write in red what was given to us, and you can
Whatever in the 175.
That's what,
I don't want 125.
Are those all? Those are all resistor values. Yeah.
those are all ohms. Think about it. If I did that on purpose to make you think, or to.
No, okay. Make you look. I wasn't looking at the board, sorry. R2 is 180.
Oh, yeah. Threw me. That's why I was looking at my sheet again. Okay, now we're at 90. What I need first is resistance total.
230.
230?
Yes.
Oh, okay, total. Yeah. The reason I hesitated is I was looking at this 90, and I was thinking of just this bottom half, but we added that 180 in. And anyone get any different from 230?
How'd you get that?
I did 180 x over 1 plus 90 plus x over 1 plus 300 x over 1 gave me a resistance down here, a total, and then I added it to the 180 above.
Oh, you know what, I must have scrapped it, because that's what I thought it is. I just got it for some reason.
You want to try it again?
You kind of messed me up by adding them before you normally look at that. You just put them in line like that, but then you're.
By not doing the little zigzag resistor,
No.
or the two resistors on the end. I'm trying to do you a favor by skipping that.
Well, the test will be that way.
The test will be identical to this. I mean, it's just like the test question.
Then you rewrite it the way you want.
But we're going to come back to that. We just don't. Those two resistors in series kind of confuse us early on. I'd rather deal with them later. So we got 230 ohms. We should be able to get a total current.
1.13 amps.
0.13 amps. So where, first one,
Yeah, I mean,
0.13 amps for R1.
Which gives you 23.4 volts for R1.
Tell me the volts again.
23.4.
23.4 volts on top.
Which gives us
6.6.
6.6 below. Yeah. So I'm gonna draw a line in here because we've got this early.
So, on a circuit like this, we're gonna throw on the right side, it becomes parallel for 300. Like on the other side of the left, let's go for it, that's all.
You lost me for a second.
So, resistor 2 sees 6.6 volts.
These all see 6.6. But see this one,
This one shares this.
when we go back to this, they'll add up to combined together. These are combined. This is R4 and 5 combined. And combined they see 300 ohms, and combined they see 6.6 volts. But we're gonna split them later. So now, what I want you to do, we got the current for the top part. That's how we got the voltage at 23.4. What I want you to do is give me the current for these three paths. You understand what I'm going to do with these last two?
So the R2 and R3 just become 6.6 volts,
They combined, they'll add up to 6.6 volts.
all three of them combined? Or just?
No, this is parallel. So this sees, each of these resistive values see 6.6 volts.
So 2 and 3 each see 6.6, and then 4 and 5 split it.
Yes.
Okay.
And that's why I haven't gotten there yet, because we can't get those voltages until we get the current.
That's where I got stuck. So.
And I want you to get the current first.
Okay.
I don't want those two to confuse you until you have the current.
So you would go.
I want you to learn that you can get the current for all three paths the same way.
6.6.
So what's the current for the 180 ohms?
0.036.
0.036.
Can you tell me how you got that?
Okay,
180.
I want current,
Yeah.
volts divided by resistance. This resistor sees 180 ohms and this resistor sees 6.6 volts.
Thank you.
Now, to prevent from confusing you, right here we got which one is that? 180 ohms, and we got the voltage. So here's where I'm at. R2 sees 6.6 and R3 sees 6.6. So this is where I want to get. This is where I get the current for R2 and R3.
Just subtract from the 30 volts, the 23.4. 20.4
We got the 23.4 when we got the current. We got total resistance, and they gave us 30 volts, so we got total current. And since R1 is all by itself, it shares that same current.
You take that current from R1 and subtract it from 30 and you get 6.6 volts.
So when we had that current, we used the current and the resistance to get volts. That we got the total current. This shares that current. So this unit C, this R1 sees 13.318, 0.13 amps.
That's 23.478 volts.
So the volts, yeah, so the voltage, this one sees
23.
23.4. Because I had these two values. I got this current from here, because they're shared. This was given to me. So I was pretty quickly able to get the voltage on top. So since it's 30 volts, I subtract my first voltage drop. And that gave me the 6.6 down here. Okay, so now what was my current for the 90 ohm?
0.073.
0.073. And how about the 300 ohm?
0.022.
0.022.
In series, that's the same.
Okay, now That's how much that path's, that's the current for that path. It doesn't matter how many resistors I put on there. I can
Oh, I
put
see.
1 or 80 resistors. They're all gonna see that same current.
I see, so, okay, so you take the total for that path, right? And that's how you factor that into your current.
Yeah, in order to get
And
the
then-
current, I needed to know the resistance total for that path.
And then you can split them and then factor your.
So you're right. Now that 0.02 is here. Nope, that's 5. Oh, no, that was 5. That was 5. Okay, so those, that's where those that was 0.022, 0.22. 0.022, come on. And then I'll 0.036 and 0.73. And now I can get my voltage for R4 and R5.
3.85. And 2.75.
Now these two will add up to 6.6. I can redraw them now if I want to. That was 175, 125.
It's easier for me to do it like that, draw like that.
To keep it this way? Okay, we'll do it again and I'll keep them that way. And we'll just, I'll write it off, the total, this off to the side. One more time. We got 4 minutes. Okay, so we're gonna do the one below it or the one next to it? 24 volts or 100 volts?
200.
Okay.
And big dog.
I'm gonna do it this way. Kind of meet you halfway. I'll do the two in green. 80 ohms, 75 ohms. I don't know if that helps, writing it that way. Those are my two resistors. And I put the combined off to the side. So we got 75, 300, 20, 80, 75. Anyone have a resistance total yet?
235.9.
I know we're going fast, but we don't have a lot of time.
Yeah.
235?
I'm gonna like short draw now.
0.19.
Just leave it at that.
Oops, wait, I'm sorry, I might have been- sorry.
I got 130.
I was gonna say.
Sorry about that.
So
No,
that's
we got
okay.
the schematic now.
It's okay.
130.7. Yep.
Anyone have any trouble getting resistance total?
What do you do? You got 75 plus.
See, I got a 75 and an 80. It was an 80 and a 75. But I wrote off to the side that combined they're 155.
155.
You don't drive?
5 points. You let me know if you're coming early on Tuesday to study, man.
130.19.
And you know, now that I think about it, with this, if we just take that resistance for the bottom part, we can take that, let's see, no we can't. I was thinking we could get the voltage drop just with that like we do here, but we need it doesn't share. Yes, we can. Okay, so what's we got our resistance,
Our current,
yeah, what's our current now?
0.768.
0.768. So we can take that with our 75 ohms and get a voltage drop. We can also take that 0.768 and this total resistance that we got, we could use that total resistance with that 0.768 and get our voltage drop by itself. So we don't have to necessarily subtract it. Does that make sense? Because this is a total resistive value, and if we combine all this into one, like, what was your resistance on the bottom part? You would have that still?
It was 55.12, I believe.
55.12.
Yeah, 55.16.
Okay. So my point was, once we have that current at 0.768, we can use each of those resistances separately with the current and get a voltage drop. We can get the voltage drop for this one and subtract it from 100. We could get the voltage drop for 55.12 and subtract it from 100 and get the voltage on top. We could do them separately. So we could get that voltage, the voltage drops a couple different ways.
Right. And that was the same as.
Because this whole section down here has a complete total resistive value of 55.12. So we can treat it as though one resistor to get a voltage drop for that section. So, okay, regardless. So we now have two voltage drops, I hope. For R1 and R2. So what's our voltage drop for R1?
57.6.
And R2?
42.4.
0.4.
4.
42.4?
Yeah.
Everyone know how we got those volts?
Right.
Because we had 75 ohms on top, and at some point you got 55.12. You had to add them together to get that 130. So to get volts, current times resistance. So I can multiply 0.768 times 75, and I can multiply times 55.12, and I will still get these numbers, even without subtracting them from 100. So in green, I use these sections. Here's, well, I don't know if I really have to write it, but I will. 57.
Explain that to me again, please.
Huh?
57.6.
This is the volts.
Right.
We got the current, right?
Yeah.
Yeah, the current is shared. This 0.768,
Right.
that's our current total.
Right.
So it's also the same for 0.76, it's also for R1, because R1's out here by itself.
And when I multiply it, I get 57.
Okay, so to current times resistance, 0.768 times 75.
Yeah, now I got it. All right.
And try it again. Try 0.768 times 55.12. We're still at the tail end.
Yeah.
So you can get that voltage drop either way. You can take the first voltage drop of 52.6 and just subtract it from 100 and get the same number. So now we have our voltage drops. So now the numbers we're going to use are these three resistances to get our current for each path. So what's our current for the 300 ohm path? Volts divided by resistance. So our volts for in here is 42.4. So 42.4 divided by 300 is how much? 0.141. And now divide 42.4 by 120.
0.353.
That's amps. Now these two resistors we're going to treat for this purpose only. We're going to treat it as one resistor. So we're going to divide 42.4 by 155 to get the current for that path.
0.273.
Everybody with me so far? I know you're confused. I see it.
You're right.
These two resistors, that's better. These two resistors we're treating as one. And before when I drew this, I didn't show these. I just kept it combined. So really, if you understood how I got these two, you get this one the exact same way. But you have to treat it as one resistor first. Because the total resistance for this path is 155. And I keep using the term path because it's a river. And these two combined resistors, even though they're in a series, the path, the circuit doesn't know the difference, whether it's two resistors in series or one 55 or one 155 ohm resistor. So to get the current, I'm using the total resistance for each path. So these three steps were identical. Now, so I come over here, R2 is 0.141, and then 0.353 for R3, and then these two are going to be the same, 0.273. Go ahead, don't hesitate to ask.
How did you get 0.353?
2.4 times.
What is it?
To get current,
Yeah.
volts divided by resistance. So the voltage drop for this whole section, this is a parallel. So the voltage drop for this section is 42.4. Each of these sees 42.4 volts.
Okay.
So I divided the resistance by 42. I divided the voltage drop by each of the resistances. That tricky part that can be confusing is I have to treat those two resistors as though they were one. Because this pathway doesn't know the difference, whether it's 2 or 3 or 4. It only knows that the total resistance that it's meeting. And listen to my words, total resistance. As this current flows through here, it's meeting a total resistance, and that affects how fast the whole thing moves. So I have to treat those as one combined resistance for that path. So I get these three currents identically all the way down. Once I know this current, now I'll split it back up and I'll put those two currents where they belong with each individual resistor. Now I can figure their respective voltage. Is this a hard one?
Starting.
When on the previous one, I didn't show you the two resistors. I kept them as one, hoping that that you would treat them all the same. I don't know which. I don't know if that helps or not.
Okay.